Hello, my name's John Lamba, and today I'm going to teach you how to make a 3D scanner. Alright, so now what I'm about to show you is the entire slideshow that I'm going to go over in detail. This will be the first video within a video series that I plan to do. However, this is the show-off video that I'm using to show off to MatLab for their competition. So what the main challenge was I wanted to be able to 3D print objects within my house. However, I'm a terrible 3D artist. So I needed to be able to 3D reconstruct. Now, there are other laser scanning programs out there. However, I could not get any of them to work for me, and I kind of wanted to build my own. So using mathematics, I set out to figure out how this is done. Now, I watch tons of videos on how people get theirs to work, and I've read hundreds of papers on how people are able to accomplish doing certain things, but a lot of them were very confusing, a lot of them were very different, and I didn't have a very clear idea of exactly what I was doing. Now, I was able to figure out a lot of these problems by a basic pinhole projection equation that really made things make sense. So I will be going over that in detail and showing you exactly how that works and how you can use that to figure out the angle of a laser even if you don't know the angle that the laser is when you set up the model in the first place, because I set up the laser arbitrarily. I just glued it in place, and using mathematics and the law of sine, I was able to figure out the exact degree at which the laser hit the back wall, and it was able to calibrate very accurately the entire model by knowing the depth of a back wall and knowing where that laser is placed and what angle at which that point is in terms of the camera coordinates. So a lot of that doesn't make sense. I'll be going over a lot of that in detail later. One of the biggest things, first thing before we start anything, is having the MatLab computer vision toolbox to calibrate your camera. There are other ways to calibrate your camera, and if people need it, I will place camera calibrations within the video description. However, a lot of the other calibration software I used didn't let me change the resolution of the camera, and that does affect the focal length of the camera. So having a different resolution in calibration will definitely screw everything up. So we have to watch out about that. Now, I'm assuming that most of the viewers have at least a good understanding on how MATLAB works, at least a basic understanding of algebra and basic calculus. Now, you can copy and paste almost all of the code, and just changing a simple set of parameters through B3D scanning without having to know any math or even any really coding knowledge at all. However, if you want to really understand what's happening, you will be able to, within this video, I will describe well enough for you to be able to transport what I teach you here into another programming language. So if you wanted to bring this into OpenCV, that will totally be something you will be able to do. Now, one thing I will also mention is that I do not have a way to print a mesh. However, there is a fabulous program called MatLab that handles all of that for me, and I do give a detailed instructions on how I go from filtering my point cloud within MatLab to give me a really accurate mesh model that I can 3D print directly after scanning. Now, the filtering method that I came out with was probably the hardest thing that I was having to do, because depending on the light and a lot of different parameters, the laser line is a lot harder to detect than you would assume. Now, I was able to read a lot of different scientific papers on how people were able to filter the images, but I found the best way was to do background subtraction. So take a image with the laser on and a laser off, and through some filtering and through some gradient analysis, we are able to generate a very clear picture of our model and a nice, very solid single pixel laser line. Because for every Y value within the image, we want just a single X pixel that is illuminated, and at that single illuminated pixel, you will find the depth.